In this example, we have a team of researchers who wants to compare the mean C-reactive protein, or CRP, levels in two populations here. And we are comparing means. So this is going to be an estimation that involves means for two populations between individuals who are diabetic and individuals who are not. So the mean CRP level for the sample of individuals who are diabetic is 15.6 with a standard deviation of 4.9, and 35 individuals were in the sample. So that means that X1 bar, our first sample mean, is 15.6. S1, the first sample standard deviation, is 4.9. And our first sample size N1 is 35. And then the mean CRP level in individuals who are not diabetic is 5.8 with a standard deviation of 3.9 and 30 individuals. So 5.8 is our X2 bar, 3.9 is S2, and 30 is N2. We want the 95% confidence interval here, demonstrating the difference in means. So these are two independent samples. They're two samples of different individuals. Some have diabetes and some don't. So this is a two sample, and also they tell us two populations. So this is two independent samples. And for the mean, for mu. So if we go to Excel, we want tab 8, which is confidence interval mean 1 minus mean 2 summary data. So two independent samples here, confidence interval for mean 1 minus mean 2. Now the other confidence interval for two samples, two independent samples, is two independent samples here with the data. We don't have the data. And then also be careful that you do not use confidence interval here for the difference of the means. That's paired differences, so this would be like before and after. So diabetic, same person, before and after treatment, second subject, before and after treatment, etc. We've got pairs of measurements, and we're looking at the mean difference. That is not the case for this example. So now we'll go ahead and enter in our sample sizes here. So that first sample was size 35. The mean was 15.6. And then the standard deviation was 4.9. And then our second sample was size 30. The mean was 5.8. And then the standard deviation was 3.9. 5.8, 3.9, 30. So with that information, press enter there, update the calculation. Our standard errors of the sampling distributions are here. The z-score used in the estimation. S of P, that is the pooled estimator. The point estimate, that's the difference between the two means, 15.6 minus 5.8. And then our lower limit for the confidence interval is the 7.621, and the upper limit is 11.979. So lower limit, 7.621, upper 11.979. So what that means is that we are 95% confident here that the true mean difference for the two populations, so the difference in the means of the two populations, so this is mean 1 minus mean 2. That's the difference in means. In the population, C-reactive protein levels between diabetics and non-diabetics is between 7.621 and 11.979. And again, what that means is if we took repeated pairs of samples from diabetics and non-diabetics, then 95% of those pairs would generate a confidence interval here for the difference of means that contained the actual population mean. So that's almost like saying there's a 95% chance that the true difference in means is in between these two numbers. It's almost the same thing.